Good morning. It's been a while. It's been about a year, but I'm back. Moved into a new office. Got lots of new projects. I'll talk about those later. Today I wanted to talk to you about a paper that came across my desk. It's interesting in the questions that it raises. So let's dive right into this. Today's paper, we're talking about the effect of 222 nanometer UVC on healthy volunteer skin, a pilot study. Interesting, many medical journals summarize the entire paper right on the first page. So here we go. Frequent topical antiseptics used on hands. So this is about hand washing. Okay, good, hands. And there's been a number of papers in the literature talking about using 222 nanometer ultraviolet for hand disinfection. Beautiful. So these guys use a sterile A disinfectant source, just one. So this is one commercially available source to disinfect skin. They measure 4 skin types on healthy volunteers. They measure their minimal erythema dose. Okay, good, some results. And the conclusion of the study is the source showed erythemogenic or CPD potential at lower doses than those required to reach the reported threshold bacteriostatic effect. So what do we have here? This is 222 nanometer light used for washing hands, and it doesn't work. You have erythema, you have skin inflammation below the dose required to disinfect. Well, we can close this paper now, ignore the rest of the pages. Just look at the conclusion. One thing I noticed before I closed this paper is look at the authors. One of them is from Gojo Industries. Now Gojo, as you probably might know, owns Purell. That's a hand washing company. And then immediately see, well, there's no conflict of interest. So how is their participation from hand washing company on a hand washing UV, which is direct competition to them, and no conflicts? Interesting. Let's take a look. In the background, this paper discusses the importance of hand washing, and obviously, methicillin-resistant Staph aureus is a big challenge. Antiseptic use to hands as many as 30 times per day is very frequent in healthcare. So developing a new device that disinfects hands may be better, safer, or faster than hand washing is an interesting challenge. I don't think there's much better than hand washing with warm water and soap, but we all use Purell from time to time. Well, anyway, so there's some stuff in the background, talks about different wavelengths of UV, and it has been reported previously that 222 nanometer UV is potentially not harmful to humans. Okay, interesting. That's the background. For their methods, they use a well-calibrated UV detector. I tend to believe it. I'm not familiar with this particular one, but I know the International Light Technologies company, and I use their products. They're wonderful. In a clinical study, they looked at 12 hours and 24 hours post-irradiation to assess the dose regime. They also did skin biopsies to look at any kind of DNA damage. Authors claim that this is first in men study. Interesting. Okay, so they recruited healthy male volunteers in single center at the National Photobiology Unit, so probably students or residents. Each subject served as his own negative control. Interesting. And they used narrow band UVB device acting as a positive control. Fine. Here where it gets tricky. They used 4 male volunteers, age range 22 to 28. Skin type 1, 2 of them. Skin type 2, 2 of them. Okay, so this is basically 1 per skin type, because 1 will be used for control. Interesting. So this is basically total of study of n equals 1. Table 1 summarizes the results, I guess. And there is some potential interesting information here. Let's read into the text. The MED is defined as the minimal dose of radiation at which just perceptible erythema is observed by visual examination. Okay, so we're looking for, looking at my skin, for example. If I rub it a little, there is a little inflammation that appears. Is it inflamed? I'm not sure. Maybe it's a little redder now. So I would say this is pressure from putting my hand on the table, and I say that's a little bit red. So this is highly subjective analysis of 4 people of 2 different skin types treated by 2 different devices. So it's basically 1 skin type per device. Interesting. This visual observation was carried out 12 hours and 24 hours later. If there was no inflammation, they proceeded to increase the dose. 4 millimeter skin biopsies were taken and fixed within 5 minutes of irradiation. There was some immunohistochemical work done, but let's look at the results. By the way, the authors themselves mention a simple semi-quantitative scoring system in Table 2 was employed to evaluate the samples. The semi-quantitative scoring system where 1 human receives 1 dose, or 1 human of 1 skin type receives 1 dose. So they measure between 4 and 6 milliwatts per centimeter squared at 5 or 2.5 centimeters. The spectrum does indeed show narrow 222. So if we look at the spectrum, this is very nice 222 nanometer signal. Looks like the lamp is probably filtered. However, when they replot the same plot on a logarithmic scale, there are some small peaks in different wavelength of ultraviolet. Okay, that's fine. I mean, 254 and 234 have been linked to some inflammation to the best of my knowledge, or 257 here. So potentially inflammation is due to that, and if it's filtered out, there will be less, but still. Take a look at this. For UVC, the MAD values in the 4 volunteers tested were either 40 or 50 millijoules per square centimeter. These results are contrary to the reported anecdotal observation that suggests that the skin might be able to tolerate as much as 500 millijoules per square centimeter without producing erythema. Where's the reference? So somebody told an anecdote that said 500 millijoules per square centimeter is tolerable, and here the doses used were 40 and 50. And they observed some erythema. Okay, I'm confused about this. When they look at histopathology, the apoptotic keratinocytes, the sunburn cells, were exceptionally infrequent, even in the UVB irradiated skin. What does it mean, exceptionally infrequent? I'm not sure. I'm not a skin expert, and maybe looking at histopathology is a very complicated process, but exceptionally infrequent, meaning they're not there pretty much, even in UVB irradiated skin. I think that's what this says. So there is not much observed damage, at least from appearance of apoptotic dead keratinocytes. Okay, so UVB irradiation resulted in strong expression of CPD in both basal and subbasal epidermis. CPD was also noted within endothelial cells lining dermal capillary blood vessels in the immediate subepidermal zone, and also within the nuclei of dermal connective tissue cells. Well, this is important. So they observe damage, DNA damage, in these cells. So let's take a look at figures 2b and 3b. I don't see much difference. So this is no treatment, this is UVB, and this is UVC. They are a little bit different, but not that much different to me. Is this enough to make the claims that the authors are making? Well, let's keep reading. I can't really see much difference between UVC and UVB, and no treatment. UVB, clearly there's some darker areas, which I believe the authors call this CPD. difference between UVC and no treatment. By the way, the red text is text I added. So are the yellow highlights. Yeah, sorry. Should have mentioned that earlier. Well, look at the caption. The cyclobutane pyrimidine dimers, the CPDs, occur throughout epidermis as shown by intensity brown staining nuclei. Examples arrowed. Do you see any arrows? I don't see any arrows. So there's nothing to show, or they forgot to add arrows. I'm not sure. Let's look at this journal. What is this journal? Photodermatology, Photoimmunology, Photomedicine, 2015. Well, I happen to have looked it up. All right. So it's published by Wiley in United Kingdom, and its SJR index is below 1. So this is pretty low index for a journal. So it's not a very major journal, so editors didn't notice that there weren't any arrows, or there are not supposed to be any arrows, maybe. Not sure. Okay, so the discussion. We have investigated both arrhythmogenic and CPD formation potential of the UVC emitting steroid device. The inter-individual results were remarkably consistent. With what? There is one skin type per device. There are 4 individuals total. 1 black guy, 1 white guy is my guess. And 1 black guy and 1 white guy that receive UVB treatment. So how is inter-individual results? And if they're remarkably consistent, they're all the same, I guess. I'm confused about this. Although 97% of the UVC was emitted at wavelengths shorter than 250, there is possibility that longer wavelengths could contribute to the effect. What effect? But okay. Now the pearl. CPDs are probably responsible for most of the DNA damage-mediated effects of sunlight. The word probably here. So if you delete it, then they're saying, look, we've observed CPDs, which I didn't, but maybe I'm overlooking something. So we observe CPDs and they are responsible for DNA damage. So that's a conclusion one might draw, but the probably here is quite questionable. No reference, so this is a claim the authors are making alone and only in this paper. Let's keep reading, we're almost done. These data, when combined, suggest that not only is erythema inducible using the UVC emitting sterile ray, but also the DNA damage in the form of skin cancer associated CPDs has also been induced. These events are occurring at steroid dosage levels below the threshold of bacteriostatic, bactericidal effect, suggesting that frequent, several times daily, use of sterile radiation is unlikely to be tolerated as a non-chemical antiseptic for human skin. Fabulous. And the cherry on this cake are the acknowledgements. The authors also wish to thank Gojo Industries for financially supporting the study and providing the sterile ray device. Well, we read this together. So at the very beginning, we almost made a conclusion that the source showed an arrhythmogenic or CPD potential at lower doses than those required to reach the reported threshold bacteriostatic effect. So if we didn't read any further, we could have stuck to the conclusion that 222 nanometer light has a potential to cause skin cancer and other major problems. But when we looked at the paper, it was only 4 patients and each one put into their own study. So it's really study n equals 1. You know, sometimes I get asked how I evaluate papers. This is how. It's published. It's accepted. It's in a peer-reviewed journal. But the journal ranking isn't the highest, which is a little bit of a question to me. Also, the study itself raises more questions than it does answers. The reason I wanted to share this with you is first to say hi, I'm back. I'll try to do these more often now that I'm fully moved into the new office. And also to point out the fact that even if it's written in a paper, in a peer-reviewed journal, if I say something on YouTube don't blindly trust. Do your own fact checking. Until next time, peace.